Hey, today I'm going to show you how to modify a toy space gun like this. Yeah. So I'm going to show you how easy it is to modify a thing like this, and how few things you actually need to do it. So let's dig in. So when I opened this up, this is what I saw, and let's start by identifying a few things in here. So you have, let's see, you have the trigger up here, and then you have this spring is important. That is what switches the thing on. So we'll get back to that later. And if I'll zoom in a bit, and then on the thing itself, well, you have 3 volts because you have 2 batteries there, and you have a 0 volt. The other side of the battery, it's there, and then you have you have a motor over here. You can I just cut that away because that's just there for haptic feedback, and it just draws power. Completely unnecessary. And what you also want to do is connect the output from this, which is the speaker output. That's the yellow lines. And we can also see that we have 3 light bulbs up here. They probably shows light bulbs because it's cheaper maybe than LEDs, or because it's easier in manufacturing because you don't have to take care of which wire you connect where, because they will be on all the time. So and what I wanted to be able to do is I would like to be able to get a gate in, and I would like to get a gate out from this so I can control other things. And I also wanted to be able to use the signals that go to the light bulbs to control stuff. So what do we have? Let's start with the PCB then. So this is the PCB on the side that you will see when you open the thing up. And it is actually, you have the trigger that connects through, you need to have voltmeter. And if you measure with the voltmeter, you will see that you will have a 0 volt here on this metal thing, and you will have 3 volts here on this pin thing. And when you pull the trigger, it will connect through this, and you will have, it fires. That's the gate thing, sort of. So let's take that away for now. So let's view it without the trigger. So a way to, if the pin, this one, is 3 volts, you don't want to just connect that to ground, because then you will short the battery, if that would be the case, but it's not inside. So if you connect an ampere meter on your voltmeter through here, so you can measure that it will be, in this case, it's less than 1 milliamp that is going through this. So what does that tell me? Well, it tells me that inside you have your plus 3 volt, and then in some way inside you have some kind of resistor, and then it goes out to the pin, and the pin is part of a switch that goes to ground. Okay, good. So and I would like to be able to control this from the outside. A good way to do that is to just do a jack, connect a resistor to that, and put a transistor that happens to be a NPN transistor, and I connect that over here. So that comes in parallel with the trigger switch. That's good, I guess. And well, you know that you will have, when this is turned on, you will have less than 1 milliamp going here. Probably a lot less. With the simple voltmeter I used, I couldn't really measure. So, and you need to choose a suitable transistor. So what did I do? Well, I looked what do I have at home. So I just took a general purpose one. So I had a BC 847C. I had a few of those at home, and they have fairly high current amplification, so I chose 100K there. But I would also be able to get a signal out from this that I can use for trigger other things. The good way to do that is you sort of listen to this signal. You set another transistor over here, same type, and you pull this up to plus 3 volts, and this is your, so this is the gate in, and this is gate out. So the good thing is that when you can connect your synth or whatever, it will see a current going this way. So it will see 100 kilo ohms. So high impedance, it doesn't affect much. And going out, the current will go this way. And if you choose to, well, of course you have to have values here. Set this to, oh, sorry, you can't see this. Sorry. I'll move it. So this one can also be 100K, and this one can be 1 kilo ohm, just for short circuit protection. And it's also because otherwise, when this transistor is open, well, you don't want to pull so much current through it, so it breaks. So that's it. So this side is inside the PCB, and the other ones, that is 1, 2, 3, 4, 5 components. That's all you need for the gate in and gate out. Okay. And if we go further and have a look at what's going on the back of the board where you could connect. A thing that I discovered was that when I was measuring on the two yellow lines, that is the lines to the speaker, I could see that both of them, both this one and this one, were at +3 volts. So let's see, what does that tell us? Well, it says that you can also see on the PCB sort of that you on that output side you have your internal you have your +3 volts, and that comes out to the speaker. Oh, see, you can't see it again. Sorry, I'm sort of new to this. It comes out to your speaker, and it goes. Well, you can see also that there is. It comes back in. It actually goes this way. Comes in here. Oh, sorry. So it comes in here, goes through this resistor, and into the control circuit. So this means that it goes back in and it goes through this. This one that is called R12, and back into the black box that is the control circuit. So what you would like to do here is connect on this side. That is this side. This will be your out. And since it's all on the plus side, you need to block it from DC, so to get it AC coupled. And an easy way is then to you just connect. Well, first of all, you need to have some kind of way to limit the current. So 1K on the way out is good, and then maybe a 10 microfarad capacitor. These two together, they form a these two. They form a low-pass filter with a lower frequency of 20 hertz, which means that whatever this thing is putting out, you will get out. And then you go to your output jack. But then there's another thing. Since everything is floating on 3 volts, and the output jack also, it's also connected to ground. Since everything is floating on 3 volts, when this side is on 3 volts and then it bumps up and down, the other side here will also adapt the same voltage. So you will, if you have a very high impedance input that you go into, you will have a DC offset there for a while before it discharges through your input. So what do you do to fix that? Well, it's easy. You just put another resistor on this side and a fairly big one, and put that to ground. So I put 1 mega ohm there, but it could be, say, it could be 100 kilo ohm as well. It's something big, but I used 1 mega ohm just to refer the output to ground, so it's not floating. Yeah, that's it. And what else on this side? Well, let's move it a bit again. So you also want to connect. Let's start with the important stuff first. So let's, oops. Okay, I'll remove. Okay. Apparently I've been drawing on the wrong layers, but anyway, it works anyway. So, and you would also like to be able to, let's see, you need to connect your trigger, and the trigger is here. That is the pin, but that's a big blob, so it's actually easier to connect to this part. So this is your gate, the gate control, or let's call that pin instead, because it is a pin on the PCB. So that should be connected to something, and that should be connected to the thing I showed you on the page before. This one. So the pin is, in this case, this one. So okay, that's that. And then we need to have the signals that are going to the light bulbs, and that is also fairly easy, because you can see that you have, these two wires go to one of them, and these two go to different ones of them. And you can see on the PCB that this and this and this are connected, and that is all connected to ground, or 0 volt. And that makes you understand that you would like to solder something in on this, and this. So that is your light bulb trigger outputs. And all of the light bulb trigger outputs you do in the same way. You go from that thing, you go out, and you go to a resistor, and to protect things again, so put 1K there, easy. And then you just go to your and you go to the output. That's it. So it's just same on the next one. You need to have a resistor that goes to the second, 1K, and to the jack out, and one more, 1K, to the output jack for the light bulbs. So you need to have a few more components here, and that is 1, 2, 3 resistors for the light bulbs, 1 resistor and capacitor, and some kind of parallel capacitor for the audio output. And then I also discovered another thing. I was going to keep the I was going to keep the speaker, I thought, well, so I can switch it on and off. But since this is not a very solid thing, the speaker broke when I was handling it. So what I did in this case, because without the speaker, nothing works, actually, which is kind of logical, because the current, in this case, it comes from here, goes through the speaker, through this resistor, and into the black thing, the control circuit. And if you take the speaker away, what happens? Well, you break that current, so you don't get anything out. So what I did, when my speaker just broke, well, okay, I need to replace the speaker, so I took a 8 ohm resistor and just soldered it in here across there, and the current can flow again, and everything works. Super simple, I guess. Okay, next I added the jacks. So in this case I decided that these two are gate, and it's in and out, and then I have these, I called them P like 0.1, P2 and P3. That's it. And this is the audio out. So I placed them there so they wouldn't be, it wouldn't interfere with my hands when I was using it. So you also have to think of ergonomics. It's even though it's a crap toy, the ergonomics is important, maybe. Okay, so let's go to this part. And one way to do, I'll show you how I do this. You can just solder things together. If you don't have surface mount stuff, you can have things with through-hole components, and you solder it to some kind of strip board, or you just solder it together as a little mess, and fix things with hot glue or whatever. But what I did it this way. So you can see that this is the same thing as I was drawing on the other page. So this is actually a picture from my journal. I always keep a journal when I'm doing things, because I can't remember all the things I'm doing otherwise. And if you put a project aside for a week or two, if you do things on the weekends and you pick it up the next weekend or 3 weeks later, it's always hard to remember what you were doing. So I always keep a journal. Done that through my design life. So the thing here that's called switch, that is the pin. where the trigger is connecting things. And it says gate kort till Spacegun. Gate board for Spacegun, yeah. And it says gate ut, which means gate out, and so on. So very simple. So what I do, I just redraw what's going on up here on the top part to how things look physically. So if I pull in a picture of the transistor that I'm using, yeah, you can see base, collector, and emitter, and it looks like this. You have 1, 2, and 3. Okay, so take that away, and what I've done is that I just did that. So I drew it the way it looks, and then it's kind of hard to see, but like this resistor here, I scratched it on this piece of laminate, unetched laminate that I had laying around, and then the transistor ends up here, that ends up here, and so on. And then there's a line over here, which means that I should cut the board there. So I'll show you how this ends up when I have cut it. So the reason I work this way is that it's super fast. So making a board like this takes me, I don't know, 15-20 minutes. It's ugly as fuck, but it's it works. So again, this one, it will end up here, and that thing will end up here with its legs 1, 2, and 3, and next one, and so on. And I still need to cut the board there, but I didn't do that yet because it's easier to handle if it's bigger. And when I put the components on, we're in this situation, and it looks messy, but it works. So you will have gate in there, and you will connect to, no, sorry, not there. And you will connect here to what I earlier called pin on the trigger. This will be the 0 volts, and this will be the 3 volts in, and finally this is the gate out. Yeah, that's it. Small, ugly, but it works. So when I solder everything in, if we start with the important stuff first, and that would probably be to connect the ground or the 0 volt. So it comes from here, and then it comes as before to the up to the board. It goes down to my little ugly board, like that. And from the little ugly board and all the connectors I've made, you see this, I just pulled the long wire all the way through here and over to the audio output. And all the grounds or 0 volts are connected. And then for the power, other side of the power, the plus, comes from here, goes up to, I put a switch here, because I thought it's probably good to be able to switch the power off completely, so there's no risk that anything is drawing power and it just discharges the batteries over time. That's super annoying. I have equipment that's doing that, like my first Zoom recorder. Super annoying. Okay, and then from the switch it goes down to the little ugly board I did, and it's also going to the main board. And yeah, you have the gate in, you have the gate out, you have the audio output from here, also goes down to there, where I have a little thing built up with a resistor and a capacitor. I just built it on the connector, and across, you can't see it on this picture, but across I put the 1 mega ohm resistor just across it. And then you have the outputs for the light bulbs. These ones goes down to the resistor 1K that I put over here, and the same on the other three. Very simple. And as I said, the speaker broke at this point, so I just cut it away and threw it off, and replaced it with an 8 ohm resistor, just to not to mess with anything, and everything works the way it did before. Okay, and here I have replaced the board in its proper position, and also here you can see the well, I said 1 mega ohm, it's actually 800 kilo ohms, because I had that. So this is the way it looks. This thing over here was supposed to be the speaker on and off. I put it far away from my hands, because that is the thing that I probably won't use at all when I'm using the gun. Yeah, and the finished product, sort of. And I've just scratched in the surface that my son had spray painted, so I can remember where the in and the out is, and so on. I don't know if you can see it, but it's the so you have output here. Oh, sorry. This is audio out, gate in, gate out, and then you have these trigger outputs. And these trigger outputs, well, I can't control the frequency of them, and I can't control what sound the gun is doing. It's actually it's cycling through 8 different sounds when I trigger the gun. So that's could be seen as annoying, or as some kind of cool option. So the output from the where the light bulbs are, I actually thought about replacing them with LEDs, but when I looked at how the signal looked. It looks like this. And the interesting thing is, if I would have replaced this with an LED, it would probably have looked like this. But because of the characteristic of the lamp, it has a low resistance in the beginning. When it's heating up and it's turning on, you get a kind of a soggy start of on the, well, sort of on the leading edge of the signal, because it's drawing a lot of power, and then the voltage doesn't have the possibility to get up to where it's supposed to go directly. So I decided to keep this, because this shape could be, if I use it to control something, then I have a shape that isn't just a square wave, and that could be interesting, I thought. And if I look at the frequency, well, they are, of course, it's you have one signal that looks like this, the next one comes afterwards, oops, like this, and the third one, so they are, well, they should be equally long, and so on. And the repetition frequency of this happens to be, it's 172 milliseconds, which is that is about 6 hertz, and you can't change that. And the pulse width on all of them are 58 milliseconds, and you can't change that either. But if you use this, you could tempo sync your whole composition and get it to be in sync, which is kind of backwards, because then you would have to tempo sync your composition to a toy, or you go with the fact that it's not tempo synced, and that could actually be a fun thing. Anyway, I don't know. I hope this was helpful in some way. So you see, it's not that much you need to do to get it to work, and it works fine. My son actually liked this so much, so he came down and gave me this thing. Yeah. So at some point later, maybe this autumn, I will do something with this. But this is big and super ugly. So what I, in that case, will do is just to saw this off and, I don't know. So, well, anyway, if you find this helpful, well, if you want to, like and subscribe. If you want to, you don't have to, but it would be fun if you do it. Okay, that's it. Thank you.